Well, Stu, we've been working on this company for several years. It's technology out of University of Illinois. It's the crowning achievement of Dr. Ken Page's life's work here, and I have the opportunity to help him commercialize that. The technology increases dramatically the yield from soybeans, so it really is a significant change forward in the world of soybeans and some of the most exciting technology I've seen in a very long time.
So what is the technology, and what does it make soybeans do?
So it makes soybeans grow. We maintain the plant populations in the fields. We increase and select certain varieties. That yield increases dramatically based on our treatment and our process. The system's called RevCell, and RevCell is the technology behind it that's all patented and licensed through the university. And that yields outsized soybean yields with the same footprint, same number of acres, and really good outcome for soybean farmers.
Okay, so we've got 110,000 population in per acre.
Yeah, typically. Sure.
Okay, and we've got 1 acre beside the other. We've got one treated. We've got one untreated.
Yeah.
What is the outcome between the two, untreated and treated?
Well, the treated would have more pods, first more flowering nodes, then more pods, and ultimately more beans per acre. But the beans themselves are the same size. Nothing changes there. A little bit of change in oil and protein content, but the beans themselves are the same as they were before. There's just a lot more of them per plant.
So more flowers, and the ones that do stay have more pods.
Right.
But
and less pod abortion too, where the pods stay through completion. Yeah.
Okay. So why does it do this? You're treating it with, you're putting on a magic chemical?
We're putting on a chemical, but really what we're triggering is a genetic evolutionary trait that plants recover from damage from predators coming in, mostly herbivores coming in and eating off the tops of the plants. We've figured out a reliable and repeatable way to do that on production agriculture scale, mimicking what would have happened in the past with, say, an elk or a buffalo population coming through and eating the tops of the plants off. These plants have developed through an evolutionary time frame an ability to recover after damage. But if that damage doesn't happen, it's a normal soybean. So we figured out how to do that in the right way to make it a repeatable, reliable increase in yield.
It's not just the saliva from the animal.
No, actually, it's not. It's the damage actually is what really triggers the plant to say, I've been damaged significantly, and I need to come back in an outsized way, or else I risk not being here next year for those seeds to then become next year's crop.
Okay. A few years back, I saw a cotton field that had been hit by hail, and the stems were about 3 inches high. And later on, the cotton plants were about twice the size of a normal cotton plant.
Yeah.
The number of bolls were twice the number. And so I'm assuming that's the same type of thing. So if the soybeans had been hit by hail, this could happen as well.
And your experience is what we hear from farmers as we go out. Our first investors in the company were farmers. And the guys that really got it up front were like, I've seen this somewhere on my operation before. You know, in past years, may have been a hailstorm, may have been some kind of herbicide drift onto their field that was unintended. They were worried that it was going to be an insurance claim for them, and it came back being their best yield ever. So we've been able to just figure out the actual biophysics of why that occurs and do it reliably and repeatably on any field.
Okay, so let's say we've got soybean field that's been hit by hail, and you think you can get 100% damage or 90% or whatever.
Yeah.
Are you applying a chemical then to that?
We are, yeah. There's an additional pass through the field early in the soybeans growth cycle, and that's when our product is applied, and that causes the growth through the rest of the growth cycle of the plant.
Okay, so it's sort of a magic chemical that makes it do that the soybean likes. Does corn like it as well? Do other crops like it as well?
We believe so, yes. And we've shown in greenhouse trials that other crops are definitely, as you mentioned, cotton, for example, other crops like this. So we've got a pipeline of development where we're working on all that now.
Okay.
But soybeans our first one. We started with soybean, and we're really excited. It's the second biggest crop in the world, and a lot of opportunity for growth in soybeans. A lot of attention's gone to corn, not so much on soybeans, and we're excited to really bring a focus for farmers in Illinois and elsewhere onto soybeans.
Okay. So it'll be available for the 2025 crop?
Not available for 25. 25 is another one of our research years. We're looking to commercial launch in 26 and full launch in 27.
Okay. So what would a farmer have to do? Does he have to, is this a dry formulation that's spread in the field? Is it liquid that has to touch the damaged spot on the plant? Or what does it require?
It's a liquid application, so it's over-the-top sprayers. So any investment in over-the-top sprayers is something that farmers will need in addition to what they may already have. Other than that, in terms of prep, we're talking about increasing yields by 20, 30%. If you're going to increase yields by 20 or 30%, your fertility has to be right. So we're also recommending that farmers start to get the fertility right for high-yielding beans. You're going to be over 100 bushels an acre in many cases in Illinois. What does that mean for how you need to prepare?
Okay, now, if they normally put on fertility before they plant the crop, should they be anticipating damage that year, or how do we figure out when we make that fertility application then?
Well, that would just be the year coming out of corn, going into soy, just in your prep for that, in terms of replacement costs of fertilizer. If you're typically getting a 70 bushel crop, you may be getting an 85 or a 90 bushel crop. Start to think about the replacement costs of that fertilizer. It's a little more, soybeans are fixing their own nitrogen. So it's not about nitrogen fertilizer, it's really about phosphorus, potassium, and some of the micronutrients.
Okay. So just plan on a high yielding crop, and if you happen to get it almost killed, then you can spray on this magic formula, and at that point it'll all pay off.
It'll all pay off. That's right. So it's a fantastic opportunity. We've shown a 30% increase it means over $200 an acre of additional potential revenue for a farmer at reasonable bean prices. So that's a great opportunity on the farm, and we're excited to see what that does for farmers too in terms of how they're able to grow their operations.
Okay, but you hit the remaining, whatever is remaining in the field, the remaining tissue, the stem, the leaves, things like that, that is absorbed, and then it takes the nutrients that's available and then grows a bigger plant.
Grows a bigger plant, yeah.
Okay. What have I not asked? It's important for farmers to really understand why this is happening.
I think what's important to realize is this is something that they may have seen before, certainly in terms of hail, as we talked about earlier, but also this is what you see in grandma's rose bushes or other tree crops where you prune them and you get outsized flowering and yield. This is something that people have understood in permanent crops for a long time, and there just hasn't been a reliable, repeatable way to apply this to row crop agriculture until now, and that's what we're excited to bring to market.
Okay. The chemical that you spray on, what does it activate something in the plant? What's the physiology of this?
It does. It triggers this response. So that's part of it, is triggering the response, but also producing the right condition for that plant to perform what it is genetically prepared to do, and it's just a trigger that we've avoided. One of the ways to think about this is, as farmers, we've done everything that we can to make sure that plant wants for nothing.
Right.
And in reality, it turns out soybeans, and some have known this, they like to get beat up a little bit, and if we do it in exactly the right way, that actually triggers other genetic mechanisms in the plant that kicks off this process.
Do all soybeans have the required genetic response for this, or do some numbers and some breeds don't have it?
Yeah, right now it's very few do. And this is almost something that's been bred out of modern soybean genetics. So we're working hard with seed companies to bring this back into popular demand.
Okay. So what kind of soybeans should we buy if we're going to be doing this?
When we go to market, we'll be recommending which ones and working with those companies to make sure farmers get the right beans in their fields.